is the lesson video for honors chemistry for section 19.5. So as always, if you want my videos in one place, just subscribe to my channel. So the last section of chapter 19 is on salts and solutions. So if you watch the 19.4 lesson video, we talked about neutralization reactions, and an acid and a base will combine to form water and a salt. So today we're going to talk about, are salts acidic, basic, or neutral? Because you may assume they're neutral, but not all of them are. So remember, a salt is a compound formed from the cation of a base and the anion of an acid. So a salt solution can be acidic, basic, or neutral. So how do we know what it's going to be? We have to look at what it came from. So if you combine a strong acid and a strong base, they will fully neutralize and get a neutral solution. If you combine a strong acid and a weak base, you end up with an acidic solution. Now a lot of you like to think it's because of the strong acid that makes it acidic, but actually it's the conjugate acid that the weak base makes. But however you need to remember it, just make sure you get it right. Sorry. So next, a weak acid and strong base will make a basic solution. So again, it's not really because the base is strong that makes it basic, it's the conjugate base that the weak acid makes that makes it basic. So that's how you can tell. So we'll look at a few examples in a minute. So a buffer is a solution in which the pH remains relatively constant when small amounts of acid or base are added. A buffer is made of a weak acid and its conjugate base, or it can be a weak base and its conjugate acid. And a common buffer that you have is your blood. Okay, so we have a very small pH range that we can stay alive in. Okay, if you notice, if it gets below 7, it's death. If it gets above 7.8, it's death. So, we need ways to regulate that pH. And so, like common solutions in lab, our blood is a buffer. So, you can make it from a weak acid and its conjugate base. So, like acetic acid is a weak acid, and its conjugate base is acetate. So, if I add sodium acetate, then I'll have some of my weak acid, my acetic acid, and some of my conjugate base, sodium acetate. And so, that's a way you can make a buffer. So how does it work? Well, it contains a weak acid and its conjugate base, so since it has an acidic and basic component, it can neutralize either acid or base that's added to it. But the problem is you can't just add forever and it always, counteracts it. Eventually you reach what's called the buffer capacity, and that's the amount of acid or base that can be added to a buffer solution before a significant change in pH occurs. So eventually, if you keep adding acid, you're going to run out of the conjugate base to try to neutralize it. And so that's when your pH will start changing. So, wow, this video is much shorter than section 19.4 if you suffered through that thing. So, what substances combine to make a buffer? Well, a weak acid and its conjugate base. Or, of course, you can say a weak base and its conjugate acid. It works either way. Alright, so number 2, it says, which of these salts would form an acidic aqueous solution? So this is where you got to look at what it came from. So it's really helpful if you memorize those strong acids and strong bases that were in a previous video. Alright, so K, the cation, came from a base. So K came from KOH. So is that a strong or weak base? Well, that's a strong base. So I'm just going to put SB. The anion comes from an acid, so you'll add H at the front. So acetate came from acetic acid, which looks like this. This is not one of our strong acids, so it's a weak acid. So remember, if we have a strong base and a weak acid, it's going to be basic, because that weak acid is going to produce some conjugate base. Alright, so let's look at the next one. So A would not be acidic. So B, Li came from LiOH. That is a strong base. Cl came from HCl. That is a strong acid. So if you have strong base, strong acid, you get a neutral salt solution. So B would not be our answer. Alright, next C. Na came from NaOH, which is a strong base. HCO3 came from H2CO3, carbonic acid, which is a weak acid. So again, we have a strong base and a weak acid. That means it's going to be basic. But remember, it's basic because of that conjugate base that's produced. Okay, I don't want you thinking it's because of the strong base, because it's actually not because of that. Alright, so our last one, the last one's a little tricky because it depends on how you think of NH4. You can think of it as NH3, which we know is a weak base. I told you that's one of the ones I wanted you to memorize. Or you can think of it as NH4OH, which is also a weak base because it's not on our list of bases. The thing is, when you have NH3 and water, it's going to make NH4 plus OH minus. So you can think of it either way, but either way, it's a weak base. And then, of course, SO4 came from H2SO4, which is a strong acid. So you have a strong acid and a weak base, so of course that is acidic because of the conjugate acid that that weak base is going to produce. Alright, so thankfully that lesson video was a whole lot shorter. Hopefully you know a little bit more about salts and how to tell if they're acidic, basic, or neutral, and hopefully you understand buffers.